Hi, my name is Michael Eastham, and I'm here to talk about my experiences setting up multi-platform Python builds with Bazel. So I work at a company called Tecton AI. We're building a feature platform for real-time machine learning, and a big part of our product is that customers can define feature transformations using Python or SQL in our SDK, and so we have Python pretty deeply embedded into our product. Why do we use Bazel? There are three main reasons. One is that our software stack is quite polyglot, so we have things like Python interpreters embedded in backend JVM and Go servers. We are cross-platform, so our developers are either on macOS or Linux. We deploy on Linux with Docker, and this was actually one of the main reasons we wanted to be able to do these cross-platform Python builds, because we want people on macOS to be able to produce Docker images with Python packages that have the correct native dependencies to be able to run on Linux. And then we also have x86 and ARM mixed in. And we also place a very high premium on reproducibility. So we're a startup. We have a pretty small team of people to support all these different platform configurations. And so having kind of reproducible and predictable builds is really important to keep our support costs down. So our Python integration kind of went in several stages that I'm going to walk through here. The first one's just getting started. So Bazel actually has built-in rules for Python. You don't need an external rule set to get started. I've shown an example here. It's just a toy example where we have like one Python library called foolib. It's got one source file. We've got a Python binary called mytool. It depends on foolib. It also has its own source file, and then it has some data dependencies. So in this case, I said it's like a C++ binary, which has been defined somewhere else. So if we run Bazel build on mytool, we get quite a few files in the output, actually. So there are a few interesting things here. We've got symlinks to the original source files. So there's symlinks to the actual source repo. We have our data dependency, which is a C++ binary, which has been compiled somewhere else and linked in here. This is some module boilerplate that Bazel generates for you. And then an interesting thing is that the actual mytool binary is a launcher script, which has been generated by Bazel, which does a few things, but the most important one is it sets an environment variable called Python path, which is how the Python interpreter knows how to resolve imports. And so this is basically how Bazel is like constructing a tree of dependencies that the Python interpreter knows how to interpret. Once that's done, it calls something called py3wrapper.sh. And what that is a shell script which like goes out into your system and it tries to find a Python interpreter to run your Python binary with. So this is sort of like the first problem you might run into, because this is obviously not very reproducible. People have different Python versions on their system, or maybe no Python version at all. So the next step is you might want to set up a reproducible toolchain. How do we do that? So this is where we start using some external rule sets. There's one called rules Python, which is sort of like additional things you can use to build Python programs with Bazel. So here we have loading it into the workspace, just like normal. And then one of the rules that rules Python gives you is something called Python register toolchains. And you can see here it's pretty simple to use. We just give it a name, we give it a Python version. And this thing is Bazel platform aware, so it'll make sure to download a pre-built Python interpreter that's the correct version for the platform that you're targeting with Bazel. So that's pretty nice. If we rebuild mytool, we can see that now instead of py3wrapper, we have a link to a platform appropriate Python interpreter. So now this is much more reproducible, which is pretty great. So after that, we've just been dealing with source files like inside our repo, but generally when people are developing Python, they want to be able to install pip packages. So how do we do that? So you start with a requirements.txt file. This is a normal thing for the Python ecosystem, nothing Bazel specific here yet. We just have a list of the requirements or the external packages we want, and then version constraints for each of those packages. And then we can hook that up in our Bazel workspace. There's another rule called pip parse that ships with rules Python. And that basically pulls in external pip packages into your workspace. And here you can see it's pretty simple to use. We just point it at the requirements file I just showed you. And then if we want to depend on one of these in a build file, we use this macro called requirement. We just give it the name of the package we want, and then we're good to go. Using Bazel query, we can kind of look under the covers a little bit of what this is all doing. So that requirement macro is actually just expanding to an external repository that Rules Python's created for us. And if we query that external repository, you can see that it's actually just a regular Py library. Basically, the rules have gone and unpacked the contents of that package into a Py library in the external repository. So it seems pretty simple. However, if you just use this as is, you're bound to run into problems. So like, here's some examples of things that might happen and have happened to me. So you might have like a Linux engineer coming to you and saying like, oh, this is taking 5 minutes to compile your Python packages on my laptop at this point, which seems very confusing. Some other people might have like build errors saying that there's no C++ compiler. But that is also very confusing because we were like trying to write Python. So, like what's going on here? To understand this, we have to take a little bit of a look under the covers of what pip parse is actually doing. It's actually pretty straightforward if you read the implementation. What it does is it takes your requirements file, and then for each line, it runs a tool called pip wheel on that requirement. What pip wheel does is it produces a Python package in a format called the wheel format, which is basically just a zip archive with a manifest saying what's in there. And then once it gets the wheel file, all it does is it unpacks it and then generates that Py library target that I was showing you a couple slides ago. So that seems pretty straightforward. So we have to keep looking a little bit deeper to figure out what's going on. And you have to look at what pip wheel is actually doing. And so what happens when I run pip wheel pandas is it looks on this website called PyPy, which is basically a public index of all of the publicly available packages that people have uploaded. It looks to see if there's a wheel file there that's compatible with my host platform. If it finds one, downloads it. But if it doesn't find one, this is where things go wrong. So what happens in this case is it downloads a tarball of the source code for pandas. It runs a file in there called setup.py. And in the case of pandas, that setup.py file is trying to compile some C libraries using like native system libraries and all sorts of stuff that just may or may not be there. And so this is basically the cause of all those problems that I had a couple slides ago. So how can we fix this? The way we went about fixing it is using something called pip download instead of pip wheel. The difference is that when you run download instead of wheel, it basically only ever downloads a precompiled wheel. It doesn't ever try to compile it itself. And it also gives you a little bit more control over the platform resolution process, so it gives you some flags you can use to override the platform instead of just always sniffing the host platform. And thankfully, as of recent versions of Rules Python, this is now integrated into pip parse. So the way you can use it is you just say download only equals true, and that will cause it to use pip download instead of pip wheel. The other thing you're almost certainly going to need to do is set up your own internal pip repository that includes pre-built wheels that aren't available on the public repository. So like, for instance, if I wanted to use a package that didn't have Linux wheels available on PyPy, I would build a Linux wheel myself from the source code outside of Bazel, and then I would upload it to our internal pip repository, which is how we basically make this all work. So that's basically everything's working at this point on a single platform, and everything's like reproducible and working, which is really nice. But the title of this talk is like, I want multi-platform builds, and part of that is doing cross-platform builds. And so how do we accomplish that? This is a little bit more tricky, but the approach that we've taken is you can basically instantiate your pip dependencies once for each platform you want to support. So you can say here, I'm looking at a Linux x86-64 instantiation. And then in each of these instantiations, you give these extra files or flags to pip download, which tells it what platform to target. So even if I run this on a Mac, this instantiation is going to download the Linux versions of these wheels. You would probably repeat this using a macro or something, but I've left that out because it doesn't fit on a slide very well. And then on the build side, all you need to do is use selects in order to select the correct instantiation of pip deps that you want based on platform constraints that look at Bazel platforms. And so that's how you kind of hook all this up and make sure that I can build a Docker image on my Mac laptop, and it will include the correct Linux version of pandas when I do that. So that's basically what we've got into so far. We've got a couple remaining pain points, one of which is that we need to maintain this like separate repository of wheels in order to have everything work. This isn't really like a Bazel problem. This is just a problem with Python packaging in general, but it is a bit painful. And then the other thing is that launcher script, which is still in there, has a dependency on the system Python. It has like a Python 3 shebang. And so this means our Docker images all have to basically ship 2 Python interpreters, which isn't great. But other than that, it's been working pretty well. And that's all I had. Thank you.